All right. So, so last class, what we have seen is essentially, you know, construct uh, bitwise operators, right? And I mean, how do we use bitwise operators? That is what something that we have seen. We have seen what is membership operator as well. And then we moved on to different types of data structures. And we began with lists, right? And to recap quickly what we have done in lists, right? So we started off with constructing lists, and we have seen that lists can take heterogeneous values, but then we'll try to run some examples today. We have seen only homogeneous values, and I think that is what the curiosity is. Are we able to add different types of elements in lists, right? That is something that we will see as we go forward. However, we have seen how lists can be accessed, right? We have seen that the elements in the list can be accessed using indices, right? And we have various indices like this 0, 1, 2, 3, 4. Then we have -1, -2, -3, -4, -5. So these are the indices that we have, and we can access the list values based on indices. And we started off with creating certain list values like numbers, but by using the square brackets and then passing values or elements separated by a comma, and then accessed the values based on indices, right? And also we have accessed it from the right side by using the index -1. So this is something that we have seen. And next we moved on to lists by uh, accessing the indices using slicing, or probably using index value starting at a particular index and then ending at a particular index, right? So the start index was given and an end index was given. So here we have numbers, square bracket 0 colon and then square brackets. This indicates that we are starting from 0 and ending till the end of the list. That is what this meant. And we printed out the values right from the beginning of the list to the end of the list. So we got all the values that were there in the list. Similarly, we sliced the list starting from index 1 and till index 4, right? Till not till the end, but till index 4. 4 was not inclusive. We'll get index number 1, index number 2, and index number 3, which is basically the second element, third element, and the fourth element. That is what we got it from this particular piece of statement. And this particular piece of statement gave us elements starting from 1 and ending till the last element, right? Or including the last element was printed. So we got 2, 3, 4, and 5. Similarly, we can slice depending on various values, and then we have seen negative values as well. If negative values is given, then it starts from a lower value and then it goes on to the higher value, right? Similar to the way the data is organized from positive lower values to higher values. That is how it tries to print out. Then we also saw, in order to know how many elements or how many values are there in a particular list, or a list, we can use the function len. This is a inbuilt function. Len and then pass the iterable, which is essentially here the list. So len of list, the variable name is numbers. So we pass this and it gives us the number of elements that are there in this particular list. So length of numbers gives us 5, right? So we'll try to move on and see how we can assign values to a particular index if it was existing. So let me try to recreate that again. So let's say I have numbers like this. Numbers is equals to 0, 1, 2, 3, 4, 5, 6. Okay. And the length of this is 7, right? We have 7 elements in this, starting at 0 and ending at 6. And now we want to get or assign a value to index 0. I want to assign 11, right? And then I try to check if the value is available or not. So I say numbers. And as we see here, we get 11, 1, 2, 3, 4, 5, and 6. So whenever we assign a value based on this index, the original value is replaced. right? So this is how we'll be able to assign values at a particular index. So this is what we have done. And let me try to rerun this again to check if the values are available or not. So we see that the values are available, but then 0 originally, which was there in this list as we have assigned, at that particular index, we have replaced it with 11. So whenever we try to assign a value to an existing index, and if the value was present there, then that particular value is replaced, right? That is what happens when we try to assign directly using uh, this kind of an assignment at a particular index. Let's say we want to maintain the number of elements that are there, but we want to add elements to the end of the list, right? Then we have something called as an append. So we will use dot operator, and then we try to append elements or add elements to the existing list, right? So append helps us in adding add new elements to the existing list. So let's say I want to add 22, right? So now this was added, 22 was added, and then let us check if it is there or not. So now I see that the last element that is there in this list is 22. So numbers has the value 0 replaced by 11 and 22 being added at the end of the list. So this way we are able to add numbers, or we can add lists also. We'll see as we go further how do we add lists of elements to a existing list. Right? This is one way of doing it. And let's say we are iterating over a list and we want to add elements. This way we'll be able to add elements to the list at the end. So we'll see how to iterate as we go further as well. Right, so let us check what is the type of this particular list that we have created, numbers. So I type in type and pass numbers to it, right? And this gives us list as the output. So I use the function type and pass the variable numbers and pass to type. And this gives us the output as list. So this is essentially a list. So list of integers or list of strings will always give us the value as list itself, right? Hope this is clear. Try to run this for the next 1 minute and then we'll go further. All right, so hope everybody is able to run them. You are able to see how to run this. Any questions on this? All right, if there are no questions, then let's try to create a new list. So I call this new list as hetero values. Okay. And then let's add different types of values to this. So I add apple, I add banana, I add again integer values. So 23, 24, 25, and 26. Now also add 23.5. Right. So we added floating values, integer values, and string values. And we call this list as hetero values. So hetero values. And if I print this, right, because the last line in this cell is the variable name. So it gets printed out even though we have not used print. Either it can do this way as well. So it prints out the list of values. So what does the list contain? List contains apple, banana, and some integer values. So this is basically a string value that we have passed. And then subsequently, we have the other values. So 23, 24, 25, 26, and 23.5. So these are the other values that we have. So let's say we want to append certain values to this, right? We can add any value to this. So let's say I want to add mango to it. So I say append hetero values dot append and say mango, right? And then we can print hetero values. So this gives us mango at the end. So this has been appended, right? Instead of, let's say we want to add string, or let's say we do not want to add the integer value. We do not want to add values that are string or integers, but we want to add a list to this particular hetero values list object. So what we can do is we can simply add something like this, hetero values dot append, and then we can add list of values. So let's say I add 33, 34, and then say I want to add pineapple. Okay. So now we have added string values, we have added integer values, a floating value, again a string value, and finally we added at the end a list of values. How did I add a list of values? Again, open square bracket, integer values, and then we have the string value and close the square bracket, right? So this is what we have added, and then hetero values gives us list of values containing different kind of objects. We have string values, we have integer values, we have floating values, and also there is a list inside a list, right? The outer list is this particular square bracket, and inside we have another list containing, again, heterogeneous values. So we have 33, 34, and pineapple, right? So this way, we have added multiple kind of values to the same existing list. So one thing to remember with respect to lists is that list can have values that are homogeneous, or we can have values that are of different objects as well. It need not be the same all the time. But then if we try to, let's say I want to kind of find the type of this. Let's say I want to see what type this particular value is, then it is basically of type list. So type of this particular list will give us list itself, right? So it does not say which value is present inside, because it is kind of, taking it as a generic thing, and then we get the value as a list, right? So this is what we get when we try to run these statements. All right. Any questions on this? See if you are able to run them quickly. So this is what we had originally. We had hetero values, apple, banana, and some integer values and a floating value at the end. And then we appended mango to it. And then finally we appended a list of values, 33, 34, and pineapple. And this gives us the list of values. And we saw that the type of this particular list is of type list, right? This is what we have done, and this is what we see here. Let's say we want to add certain values and then order them. Let's say we want to add the timings values, right? Let's try to do this. So let's say I want to create something like this. So we have timings is equals to 130. And then we have value as 230. Then I create the timings values, which are slightly, separated by 1 hour. So that is what I'm trying to add. Then 530. So there is one question which says, how can we add or append the values of other lists in current lists? So, okay, so there is a question like this. So let's say I have something like this, right? We had hetero values, right? And hetero values was something like this. Okay, let's say I have another list. I call this G list. Okay, and then I have values like carrot and then spinach and then cabbage. Let's add these things. So we have something like this, like G list. Okay. So now, let's say we want to see something like this. Hetero list is equals to hetero values plus G list. There are multiple ways of doing this, but however, this is one way of doing it. Let's see what we get. So hetero values, right? Now you have hetero values, and then you have carrot, spinach, and cabbage at the end, right? Is this your question? How do I add some other list to the existing list? We can do something like this. We can add G list to hetero values. All right, so this is how we'll be able to add it, and you get the values appended at the end. Okay, so that is one way of doing it. And there are multiple ways, but then this is something that is kind of straightforward that we'll be able to do it. Okay, so let's say we are doing something like this. We are adding timings, and then we'll see how we can use this particular list and see what could be done with this. We'll try to perform certain basic operations. And then I have timings. Okay, so this is what we have. And then I want to get the first few values out of this. So I say, yeah, zeros, 0 to 3, right? The first three values are given. So 0th index, first index, and the second index. So we had the values like this, 130, 230, and 330. And what we have given is basically the indices, timings, square brackets, and then 0, colon 3, and then close the square brackets. So we get the values starting from 0 and ending at the index 3, right? This is where it ends, but then it does not cover 430. It covers only 0, first, and the second index. Okay, that is what it gives us the values. So similarly, if you want to slice this, right? Let's say we want to slice from 2 to 4. We want 3 elements. Indexes 2 or indices 2, 3, and 4. That is what we want. So we can specify something like this, timings of 2 to 5, and then we get 330, 430, and 530 as the values. Fine. And let's say we want to get it from index 4, then we can do something like this, 4 to end. This is something that we have seen. So we get something like this. Right? These are the basic ways in which we can slice them. This is something that we have already seen. But then let's say we want to reverse this. There are multiple ways of reversing it. So I can reverse something like this. Reverse colon colon minus 1. Right? This reverses the indices or reverses the entire list. Right? Unless and until we save this into something, this is just an output that is held, but it does not save it into timings, right? Timings is still the same original index. It does not reverse it. The original timings that we had is still starting from 130, 230, 330, 435, 36, 37, 30. But when we do this colon colon minus 1, this reverses the list, and then we get 730, 635. This is what we get. It does not really store it something. So if you want to store it, right, let's say we want to store this reversed index or reversed list with these indices that we have. So we can do something like this and then print this out. This would be a reversed list with the original values that are there in timings. All right. So this is one way of reversing it. And then let's say we want to reverse it using some function, right? So I say reverse timings dot reverse. We use the dot operator and call the reverse function. So I call this something like this, timings dot reverse, and then if you specify timings, then you will have values the same, but unless and until you store it somewhere, right, that wouldn't be available. Okay, so we can also reverse using reverse, or if you want to print that out, right? So let's say I store this in T2 and then print T2. Oops, so something went wrong. Reverse. And let me try to print timings. Now it shows the reversed values, right? So that is how we'll be able to get the reversed value with respect to the reverse operator or the reverse function. But when we do with minus 1, it tries to show us the values as it is. It does not really change the original list. But when we do a dot reverse, it tries to change the original list as well. All right, so any questions on this till here? All right, so if there are no questions, then we will try to move ahead and see what could be done next. All right, so we will try to do another function called as insert. Let's say we want to insert a value at a particular index, right? So we already have timings, right? And if you want to retrieve this index of, let's say, the value 630, right? Let's say I want to get the value of 630. So I should do a dot index. Right, it gives us the value of 1. So 630 is available at index 1. This is 0th index, this is first index, this is second index, this is third index, fourth index, fifth index, and sixth index. So the value at the first index is 630. So we want to get the index value at where the value is 630, right? So I specify something like this, timings.index of 630. Wherever 630 is there, we want to get the index of it. So we get 1. Right. Similarly, we want to, let's say, insert at index 1, the timing probably here 6. Okay, let's try to insert 6 here. We want to insert something like that, or probably it is decreasing, right? So let me try to insert timing at 1, which is 7 p.m. Okay, or 7. Right. And now if I try to see what timings is, right, it says 7:30, and then we have 7, 6:30, 5:30, 4:30, 3:30, etc. So now the timings at index 1 is 7. So whenever we want to insert an element at a particular or a specified index, then we provide something like this: insert the index value and the value that we want to insert it. It need not be 7. Let's say you want to add some string value or probably an integer value, or if you want to add a list also, that is fine. We'll be able to insert that. Fine. So we can insert a particular value at an index using this insert function on the particular list object, right? So we move on to the next function that is there on list, which is called as remove. Let's say we want to remove an element from the timings list. Let's say we want to remove now 7 that is available. So what we can do is we can say specify something like this, and then we pass in 7 to it, right? So timings.remove, and then we pass 7, and this gets removed. And what we have in timings is, oops, oh, already removed, right? So, okay, let me try to add this again, and then we can remove it, right? So let me try to execute it. Now it is removed, right? We cannot remove an element that has already been removed, or if it is not existing, we cannot remove it, right? So that is why the error that has occurred. So timings.remove 7, and then when I specify timings, you'll have the output which was original without the 7. right? So we can remove this element in this fashion, and pass the value, and that particular value would be removed from the list. Let's say we want to remove or get the element that is at the end, right? So we can say dot pop, right? And then we see, let me try to do this. So now what is the element that is there at the last, which is 130. So when we popped it, right, 130 came out, and then we still have these values. So there is no longer 130 in the list. That has been removed. Pop kind of removes the last element that is there in the list, and the other elements are there in the list itself, right? So an element is removed using pop, or if you want to remove the value itself, we can use the remove function. So these are the two ways in which we can remove elements from a particular list object. All right, so any questions on this, folks? All right, so if there are no questions, then we will move ahead. So the next function that we are going to see on the list is basically sort. So if you want to sort something, right, we can do something like this, sort, and it sorts the underlying list. So previously we had 730, 630, 534, 330, and 230. Now let's see what it does to the values. So it sorts in the ascending value order. So we have 230, 330, 430, 530, 630, and 730. Right, so sort function kind of sorts the list in an ascending order, or an alphabetic ascending order, or an alphanumeric ascending order. Right. So when we call the sort function on the list, it tries to sorts the values and gives the output. So the underlying list is sorted. Okay, so let's move to the next function, which is extend. I hope this is clear. So now we will try to add a list using the extend function. The extend function can be used in order to add lists. So this helps us to add an iterable object to it. So we can add an iterable object. We already have the timing 7:30, right? So let's add the other timings. Let's say I want to add 8:30, 9:30, and 10:30. So let's say we want to add these values to the list, and we'll be able to add it, and then we will be able to check the timings of it, or we want to see what has been added. We'll try to print that out. So add this, and then we see what is there in this particular list. So we see that 8:30, 9:30, and 10:30 has been added. So this is also one more way of adding a list to an existing list, right? Let's say we add another list, right? Let's say we use the plus operator initially. So let's say I have midnight timings. So I call this as midnight timings. And then I call this as 10:30, 11:30, and 12:30. So we have list of values like this. And then we want to extend the timings that we have, right? So I call this something like this, dot extend, and then pass this particular list value to this, okay? And then we see what is there in timings. So now we have 10:30, 11:30, 12:30 also being added to it. 10:32 is twice because we have added it once again. So that is why it has appended twice. So list accepts duplicate values, right? It does not ignore them, but instead accepts them and then adds it to the list, right? That is what list can do. Okay. So this is how we can add one list to another list. There are multiple ways of doing this. We have seen one way. This is the second way of doing it. All right. So any question, guys, take about next 2 minutes. Try to run them in your environment, and then we'll move ahead. All right. So hope everybody has completed till this point. Let's try to iterate over the existing lists that we have. So we can use the for loops in order to iterate over. So we can use something like this for timing in timings, and then we can print the output. So the time now is right. There's one way of doing it, or if you do not want to use format, then probably we can use something like this, right? We can also do something like this. Right, so we get the value printed out, right? So for time in time, for timing and timings, we want to print the value out. So the time now is 2:30, 3:30, 4:30, etc. till 12:30. All right, so this is how we can iterate over a list using the for loop. Now let's say you did not understand. Okay. Right, we already had this timings, right? We had the timings that we created. We extended, and I'm using the same timings list object. So what I did was I iterated over the timings. Now we can use for loop, especially in Python, on iterable objects. We had seen using range. If you remember range, right? We created a variable, right? What is a variable? A local variable was created, and I said in the range object, we have something like this, 15, and then I is a local variable, right? So instead of I can have timing also as a local variable. And then I printed out something like this, right? Print timing. So it prints out the values like this, correct? We know this. And the same thing, instead of range object, I used timings here, right? So rather than using the range object, I use timings. That is what I have done below. So let me remove this cell. And we see this the same thing here. So for timing and timings is our previous object that we have created. And timing is essentially the local variable that we have. And then we are trying to use the print formatting. So print, and then if I use F, it means that it is formatting. And then the time now is I pass this variable directly here. If we have any local variable within the scope, then we can directly pass this. Or if this is slightly confusing, then what I'll do is I'll remove this. Right. And then I'll also say format. And then this timing value that is there, right? So in timings, let me try to bring this out, okay? Timings, we have these values, right? So the first value is 2:30. So 2:30 is replaced in this placeholder. So it prints out the time is 2:30. Next time it comes over. So there is nothing below this for loop. So it again comes back to the second. So it kind of iterates over this list. The first time it comes is at this particular value. Second time it is here. Third time it is here. Fourth time it is here. Fifth time it is here. Sixth time it is here. Seventh time it is here. Eighth time it is here. Ninth time it is here. And whatever the values that are there after that, which is 10:30 twice, 11:30 and 12:30, that is what is also being. It traverses the list, right? It traverses from this end to the end. And that is what this timing variable is doing. Each time the new value comes in, it is stored in this timing variable and it could be used. And that is what we are trying to use this in the print statement, right? So every time we iterate over, timing value changes with the new value, wherever it is pointing. For the first time, it is pointing at 2:30. Second time, it is pointing at 3:30. Third time, it is pointing at 4:30. The next time, it is at 5:30, so on and so forth, till it reaches the end of the list. And as you see here, timings has values from 2:30 to 12:30, where 10:30 is repeated twice. That is what timings has. And we try to iterate over, and every time the value is iterated over, we hold that in timing, and then we print out that value, right? That is what we are trying to do here. Okay, so that is what we're trying to do here. And let's move on to the next function. Let's say we have something like this. And we have numbers, okay? And the values are 10, 11, 12, 13, 14, 15, and 16, right? So this is a list that we have constructed. Now we want to iterate over this list. We can do it in multiple ways. One is while loop, the other one is a for loop. Probably we'll come back to it again, but then we'll do it in the most, the way that we generally use for the range object. So I'll say for I in numbers, or let's say call this variable num, okay, in numbers. So for num in numbers, what we'll try to do is we'll create a sum, or rather than even doing this, let me try to first explain what the sum function does. So let me try to do this, sum numbers. Okay, and then I pass this to print, and then I say the sum of numbers is sum of numbers. Okay, that is what I do. Fine, the sum of numbers is sum of numbers. And then this might not work because I have to close the string. So I close this. The sum of numbers is sum of numbers. All right. So, and what is there in numbers? Numbers has 10, 11, 12, 13, 14, 15, and 16, right? These are the numbers that are available. So I print the sum of those. So we get the sum of numbers is 91. So what did the sum function do is it took all the numeric values, sum them up, and print out the output. That is what sum does. Let's say I put mango here. Okay. Instead of 17, I put this single quotes mango, which is a string value, and it says it's an error. We cannot sum these things, right? So this doesn't work. So all that it needs is integer or floating type of values, and it sums them up. So if we had this should also be okay, and it gives us 91.0, the floating value, right? So this also works. So it should accept only integer because that is where we can perform the addition operator or the summation can be done. So when we apply sum, what it does, it gets all of these elements and adds them up. If they are numeric, all of them should be numeric, only then this works. Otherwise, we have seen it throws an error, right? So this is what it gives as an output, right? Sum of list of int values or floating values or int and floating values will give us the total sum of all the numbers that are present inside the list. Fine. This is what is printed out. So we get 91 here. Any questions on this? Right. So sum does this. And if you want to do it the same thing using for loop, right? So what we do is I create a list called as int list, and then I have some numbers, the same numbers that we have. So I enclose them in list. Okay. And then I create a variable called as slist is equals to 0, which is nothing but sum of list. And first thing that I do is I iterate over this list. I call this for num in int list. Okay. And then every time we get a number, we have to append it to this particular value, or not append, we have to sum it, right? We have to sum it up. So this should be something like this. Slist is equals to slist plus num, right? Num is something that changes, but we have slist which has been declared 0. So we have declared it outside the for loop. It is not initialized again and again. It is initialized only once. So we will be able to assign it to slist. The same thing can be written. So because we have slist like this, we can write something like this. Slist plus equals 1 or equals num, right? So we can also do that. So slist is equal to slist plus num, or we can write in this fashion as well, slist plus equals to num. But instead we'll leave it there. We'll write slist is equals to slist plus num. And finally, we will print the sum, right? The sum of list of numbers is slist, right? We get as 91. Fine. So the same thing, what we have done here, so there are certain functions in Python that can simplify or remove some of these lines of code. Right? This gives us a one-liner code to find the sum of numbers. All right, till here, any question, folks? Please try to run this in the next 1 minute, and then we'll go ahead. All right, so if there are no questions, let's move ahead. So next thing that we'll look at is for comprehensions, right? Now, for comprehensions are essentially a way of comprehending the for loop. That is what we can say about for comprehensions. Instead of writing the loops multiple times, we can write this in a single line. Let's say we want to find the square of numbers, right? And then we want to get the list. What we do generally for this is, let's say if I have to do this using a for loop, I want to find square of numbers using a list. So what we'll do is, first thing, I'll create an empty list. Let's say I want to create a list. I call this as SQ list. Okay. And then I create an empty list and square of first 10 numbers. Rather than this as well, I'll say square of first 5 numbers as an example. Okay. 5 numbers. Okay. So how do we get this 5 numbers, right? So I'll call this something like this, range of 1 to 6, right? This will help us get the first 5 numbers. I want to remove 0, so I started it with 1 and ended at 6. Now, every time we want to do this, we will do something like this, dot append. We have an append function, right? If we want to find the square of list of numbers, we have the append function. Now, we want to add the square. So how do we add? So I say I into I. Every time I iterates over this range will give us a sequence of values starting from 1 and until 6, everything would be included. 6 would not be included. That is, it is not inclusive. So we can iterate over this. So SQ list dot append I into I. This is what I'm trying to do here. And this will give us the output. Now, how do we know if this is there? So I come back, go back to the place where for is. So the indentation is removed, and then I type print here. Instead of typing print here, I'll not type print here. Otherwise, it would print each and every time. So I want to print it only once. So I do this here, SQ list, right? And this gives us the output 1, 4, 9, 16, and 25. So this is how we write the code using for loop. The same thing could be written using while loop. So what I would request you is to try while loop for first 5 numbers, so square of first 5 numbers using a list, and see how it works. Probably later as an homework assignment. So you can try this later. So just try to check this, how we can do this. And then we are trying to do this. So this does not work. So while loop also, you can try this. Okay. So it is same, but except that we might have to consider the index. That is what we might have to do. So squareless, we are trying to do this, and then it prints out the values. So next thing is for comprehension. So what is for comprehension? What are we comprehending, and what is that it is minimizing? So the same code that we have can be written in one line, right? So I say something like this. I open the list. I write this for loop. So I say for X in range of 1 to 6. All right. So I have something like this, range of 1 to 6. And whatever we want as the output, right? We want the square of this value, right? Square of this value. So I write X. And how do we get the square? X to the power of 2. Or we can write X into X. Both mean the same. So I'll use the other option, X to the power of 2, right? So we have this. And then for X in range of 1 to 6, we have this. So what is happening? It is iterating every time for X in 1 to 6. And every time it is iterating, the return value is X to the power of 2. So first time we get the value as 1 to the power of 2. Second time as 2 to the power of 2. Third time as 3 to the power of 2. Fourth time as 4 to the power of 2. Fifth time as 5 to the power of 2. So each and every time it is iterating over, and then we are getting these values. So every time what it does is it stores that value, and then the next value is separated by a comma, and then we get the list. So this expression of writing the for loop in a single line is nothing but for comprehension, right? We can have 2 multiple loops or 3 loops, and then the condition also. But whatever has to be returned is written here. So now we are writing something like this, X to the power of 2 for X in range of 1 to 6. And this gives us the output. And if I type in Y, it should give us 1, 4, 9, 16, and 25. Right? Hope this is clear. The same thing what we did using for loop. In for comprehension, it returns us the list object back. If we had not had this list object, it will not be appended to this, right? Unless and until we append it, we call this explicitly, this is not happening. But right now, here, we do not have to create this list. For comprehension for list is essentially returning a list object by using a for loop and iterating over. The return type is anyways a list. Here, we have to explicitly specify, right? So the input is essentially a range object, and the output is the square value, and that is enclosed in a list. Is this clear, guys? What is the for comprehension? Okay, so when we try to do this, right? Let's say we are trying to do this in the for loop, right? Let me try to do this again, and only if the number is even. So let's say I want to get till 11, and only if the number is even. So let's say if I percentile 2 equals to 0, and I want to get this. So I say this thing, right? So the indentation is applied. right? So what are we trying to do here is we have SQ list is equals to empty list. For I in range of 1 to 11, I have a colon here. When I hit enter, it anyways provides me the indentation that is required. So the indentation is provided and the if condition starts here. So if I percentile 2 equals to 0, indicating that we are checking the even condition. If the number is even and I hit enter, again, it comes to the next line. The indentation is provided again here, right? This is the indentation under the if loop and this is the indentation under the for loop, right? This is what happens here. And we are using the object that we created, sqlist.append I into I. Only when the number is even, this has to be performed, right? So we get only even numbers. So 4, 16, 36, 64, and 100, right? These are the even numbers, or if you want to print them out, we can print them out while we do this. So it is 2, 4, 6, 8, and 10. So starting from 1 and ending until 11, these are the even numbers, 2, 4, 6, 8, and 10. And we find the squares of these even numbers only. Now, this is how we use using the for loop, right? For loop is, this is how we use using the for loop. Let's say we want to do this using the for comprehension. The same thing we want to do the for comprehension. We can write this in one line. So for I in range of, what is the range? 1 to 11, right? And then what is our condition? We specify here, I should be even. So I percentile 2 equals to 0, or I moduli equals to 0. And what should be written? I to the power of 2. We write it at the beginning. Okay, again. First thing is whatever we want to iterate over. This is what has been written here for I in range of 1 to 11. And the next thing is this should be even. How do we get this as an even? So if I percentile 2 equals to 0. So whatever is I should be even. So we iterate over and this is checked. Once this is checked, whatever is the output, we write it here. I to the power of 2 and enclose that in square brackets. We get y as even. So we get the y value as even. Right? So we can also specify conditions within the for comprehension. Guys, any questions on this? Is for comprehension clear? Okay, so let's take another example. Let's now take a string list and try to do a for comprehension on that. Okay. All right. So let's say we have the names like this. Let's try to do this. So we have names is equals to some list of values. I have Sunday and then super and then semiconductor. Okay, I say non-conductor. Then let's say we have Maggie. Then we have special, some values, or let's name this is autonomous, something like this. Okay, and we want to kind of get the values from this list using for comprehension. So for your exercise, probably, try to iterate over using for loop, get values that start with S. Start with S, and the values that are there should be present as a list of values with starting letter S. Okay. So this would be your exercise. You can practice this using the for loop or the while loop, but then we'll try to check this if we can do this using for comprehension, right? So we have names. So I'll try to open up the list and then try to write something like this for name in names, right? So if name starts with starts with, and what is this? It should start with S, right? That is what the condition is. It should return name, right? So for name in names, if name dot starts with S, then that should be only considered. Okay. This is what for comprehension is. And then let me execute this. And then we see the values of Y. So we get values as Sunday, super, and semiconductor. We don't get non-conductor, Maggie, and autonomous. Okay. That is how we are able to get these values. So what we have done in for comprehension is that we are trying to write this code in a single line. The same thing could be run using for loops, but I would want you to do this as an exercise using for loop. Try to do the same thing, iterate over this particular list of values, then see or then apply the condition, which values are starting with this, and then append that value to an existing to a new list, and then print out that list, right? That is what we see here. The same thing can be done using for comprehension. All right. So any questions on for comprehension, folks? All right. If there are no questions, then we'll move on to the next data structure, which is basically tuples, right? So far, with respect to lists, what we have seen is the various functions, how to append a value to the list, how we can iterate over list, and what are for comprehension with respect to list, right? That is what we have seen. Now, let's say we want to have elements that are immutable, right? In a particular data structure. In such cases, we can go for tuple. Because with lists, we have seen they are mutable. Whenever we try to assign a value to an existing value at a particular index, right? Then we can overwrite it. That is what we have seen in one of the example previously. Now in tuple, let's say we want values that are immutable or something that cannot be changed. Once we create a container or once we have a data structure with certain values, we do not want to change it. Then in such cases, tuples will be helpful. Tuples are essentially data structures which are immutable in nature, and we can still access those values based on indices, and we can also iterate over the tuples. That is also something that we will be able to do so. Right? So, but how do we create a tuple? One of the ways of doing this is we create something like this. Let's say I have a variable tup1 and we use parentheses, and then I pass values like 25, and then I pass mango, and then I pass Rajesh, and then I pass certain other values. Let's say I pass 40, 25, 24, and 25. So I am passing values like this. Okay. And when I do this, it gives us the values, right? So tup1 will give us a tuple. So we use this parenthesis and then pass the values to it. So these values that are there are essentially the elements of the tuple. So we have 25, Mango, Rajesh, 40, 25, 24, and 25. These are the elements that are available in tuple. Okay. So if I want to retrieve the, let's say, second value, right? We do the same thing as we did in list. So the index is 1, second value, because this index starts from 0 and this index is 1. So I call this something like this. So tup1 of 1 will give us mango. So the index starts from 0. This is 0, 1, 2, 3, 4, 5, and 6. So there are about 7 elements, and the index starts from 0, and the last index is 6. So this is how we'll be able to retrieve the value that is there at index 1, or the second value can be accessed using the index 1. Now let's say we want to iterate over the tuples, right? We can use for loop. Again, I create a local variable. Let me call that local variable x, and then I iterate over this tuple that we have created, and then we want to print them out. So I say x, print of x. So what we have done is we have created a local variable, and this x iterates over the tuple, right? It iterates over 25, Mango, Rajesh, 40, 25, 24, and 25. It iterates over this, and then we'll be able to get the value. So this is how we'll be able to get the value in the tuple. All right. So any questions on this, guys? How are we iterating over the tuple? Right. And as I said, tuple is immutable. Let's say I have something like this, and then I want to assign some value to this tup tup1, right? Let me make this tup1 of 1 is equal to 45. Now what we got is a error. It says that tuple object does not support item assignment. And what is the type of error that we got? It is a type error. Okay, because this tuple object cannot have values assigned to it. Once the values are initialized, we will not be able to assign them again and again, right? We will not be able to. That is where tuple is immutable in nature. Tuple is basically immutable in nature. Fine. That is what we have done. So next thing is, let's say, guys, still here, any questions? This is similar to list, except that we'll not be able to assign elements to it. Any questions on this? All right. If there are no questions, let's see how do we count the elements that are already there. Let's say we have 25, and as we see, 25 is occurring thrice. So if we use the count function on tuple, right? tup1.count of 25, this will give us the value as 3. So the number of times an element occurs within the tuple is given as the output. So when you apply this count and pass the element value and call it on tuple, right? The tuple is tuple1, then the value that we get is 3. Okay. So similarly, if you say tuple1 count of, let's say we had mango. Did we have mango? Yes, we had mango. Let's try to see if it gives us 1. It gives us 1. And for elements that are not there, let's say I call count of 44. It gives 0, right? This element is not available. It gives us 0. So if you want to know if a particular element is occurring, this is one way of checking it. The other way, let's say we want to check if mango is available in this particular tuple, right? So it gives us true. So one way is to check the number of times it is occurring, or we can use the membership operator and also see if it is available or not. So mango in tuple1 will give us true as the value. These are the two ways in which we will know whether the tuple has certain values or not. Fine. All right. So any questions, guys, till whatever we have discussed? All right. So if there are no questions, then we'll stop the class here. We'll meet tomorrow. Till then, goodbye and good night.